Right, we are here to do polynomial division, and we have been given like 6x to the fifth power, or 6x to the power 5 plus x to the fourth power minus 2x cubed minus 5x squared minus 1, all divided by 2x cubed minus x squared plus 1. And now we need to prepare a solution to these using the box method of polynomial division. And we proceed as follows. Right, we have noted there the polynomials that we need to divide. What do we do in the box method of polynomial division? We take the 6x to the fifth power and we drop it here. Always we put it in this block, like so. And then we consider the divisor. So we're going to put here, for example, 2x cubed. Right, so but we must have like all the terms in descending power of x from x cubed until we reach the constant. So we're going to have like the 2x cubed, and then the next one is going to be like the minus x squared. After the x squared, we need an x term, but there's no x term here because it's x squared then 1, no x term. So which means that we're going to have what? So it means, as a matter of fact here, we're going to have 0x because there's no x term like 2x, 3x, or anything. And then now we drop the 1, which is the constant term of the divisor. The denominator is called the divisor of this particular rational expression. So now what we do, we divide 6x to the fifth power. We divide it by 2. What is 6 divided by 2? 6 divided by 2 is 3. But x to the fifth power divided by x cubed is actually x squared. If you multiply 2 times 3, it's 6. X cubed by x squared is x to the fifth power. Okay, we multiply therefore minus x squared by 3x squared, which means you have minus 3x to the fourth power. You multiply 0x by 3x squared, you have 0x cubed. You multiply 1 by 3x squared, you have 3x squared. And this is what we get. Now, the next thing we're going to do is we realize the nature of this because it's cubed, squared, first power, and constant. So here is to the power 5, to the power 4, to the power 3, to the power 2. The next thing is we look at diagonal additions. So we need to decide what to put in here. But whatever we're going to put in here must diagonally, when added to minus 3x to the fourth power, it must give us x to the fourth power. And it can only be 4x to the fourth power. Because 4x to the fourth power minus 3x to the fourth power is the x to the fourth power in the numerator. So we divide this point here, right? So we divide 2 by, rather 4 by 2, and we get a 2. Right, we have x to the fourth power that is divided by x cubed, and it's only x, like so. Right, so that now if you have 2x cubed by 2x, it is 4x to the fourth power. Minus x squared by 2x, it's minus 2x cubed. 0x times 2x, 0x squared. 1 times 2x.
Sunshine?
Yes, please, 2x. Okay, are you able to see?
Do you mind? Yes. Do you mind explaining again from 4x up again?
Okay, from the 4x to the fourth power.
Yes.
All right, yes, because now the 4x to the fourth power, you look at the diagonal entries here. So after you got all these here, you need to look at what you need to put here, but it must correspond diagonally with whatever is here. And so now here we have minus 3x to the fourth power, and now we must add another x to the fourth power and put it here. but we must decide what to put as the coefficient of the x to the fourth power, because this is already x to the fourth power, there must be x to the fourth power. So whatever we must add to minus 3x to the fourth power must give us the x to the fourth power that's here. So it's only one x to the fourth power here. So it means, therefore, because this is already minus 3, so we can only put a 4, because 4 minus 3 is 1 x to the fourth power. So that's why we must put 4x to the fourth power, because 4x to the fourth power minus 3x to the fourth power. It's like 4 minus 3 is 1, but it's just that x to the fourth power that is there. And then after that, obviously, I mean, we do division. So if you have 4x to the fourth power, like what is 4 divided by 2? It's exactly 2. X to the fourth power divided by x squared. Right, so yeah, so the 2x cubed by times, that's 2x cubed times 2x, you get 4x to the fourth power. Then minus x squared by 2x is minus 2x cubed. Okay, I know you're seeing this for the first time. Right, so 0x times 2x. Like first you multiply 0 times 2. What is 0 times 2? It is actually 0. And then now x times x is x squared. Okay, so 0x times 2x is 0x squared. And then 1 times 2x is actually 2x. Next, now we must put in something here. But clearly, you can see diagonally there is a cube here. So, and obviously, there's another cube here. So you consider like all the cubes all the way to the top. So, okay, there's a cube here. There's a minus, so you always compare the cubes to whatever is in the numerator. So there is a minus 2x cubed that appears here. So if then, what can we put here? So that when you add these x cubed, that x cubed, that x cubed, you get minus 2x cubed. What can you put? Okay, this and this is minus 2x cubed. So you can see that you just need to put a 0. You need to put a 0x cubed, because it will be 0 plus 0, which is 0, and 0 minus 2 is minus 2. And then each one is x cubed. So that now you have 0x cubed divided by 2x cubed. So what does that give? It gives a 0. Right, because if you obviously divide that way, you take note of the division. What is 0 divided by 2? Okay, 0 divided by 2 is actually a 0. And then the next step is to multiply everything. Like you can multiply the 2x cubed by 0. 2 times 0 is 0. And then there is x cubed there. Or you can say 2x cubed by 0, which is 0x cubed. Then minus x squared by 0. What does it give us? It gives us 0x squared. Like so. Next, you have 0x times 0. 0x is the answer. 1 by 0. 0. Then the next thing is, what do we do? Because now we are in business. We surely are in business, and we proceed with ease. Okay, I'm going to pause this video, and then, yeah, we shall continue with our discussion a few minutes afterwards. Okay, right. So now let us do this. If you look at the quadratics now, because if you want to put anything here, it must correspond to what diagonally appears here. And there is an x squared, there is an x squared, there is a 3x squared. But if you add these with these, all the x squareds, they must give you the x squared term in the numerator. So, but if you check carefully here, 3x squared plus 0 is just 3x squared. What can we add here? What can we put here so that these added to the 3x squared would give us a minus 5? Can only be a minus 8. Minus 8x squared. Right. Now, there's something I need to mention as well in passing, that here, when we do this kind of division using, we call this the box method. Some people call it the area model, because in the end, these are like small areas we're dealing with. Or some people call it the generic rectangle method of polynomial division. Now, you are dividing a polynomial of degree 5. We say it is of degree 5 because of the x to the power 5, but we divide it by x cubed. So now, if you have x to the power 5 divided by x cubed, you get an x squared. Now, this x squared basically is of the form ax squared plus bx plus c. And because of the quotient after division, it's a quadratic, because we're only focusing on x to the power 5 and x cubed, and we leave everything else. Want to understand what we expect the answer to be, because that's how we reason this out. So right, so we continue. We continue. Okay, I think I might just be right back. It might just be network. But you're still here. I can see you. Are you still here?
Yes, Ryan, I'm here.
All right. And are you able to see now?
Yes, it's back on now. It was
Okay, thank you. It
gone.
was just the network because I was here. I think it was just the network.
Oh,
My apologies. But it's
I
being
thought you
recorded. I
were
mean, you'll
using.
be able to watch like everything. So I was then saying, if you divide an x to the power 5 by x cubed to a polynomial, x to the power 5, you divide. So 5 minus 3, you subtract the exponents. 5 minus 3, you get a 2. So it's x squared plus bx plus c, x squared, bx, and c. So it means this describes the size of the box. So because now if you have x squared, bx, and c, x squared, bx, and c, it means you'll need 3 columns. But now for the side rows, you look at the divisor, and it's 2x cubed. So you must have all the powers of x up to the constant 2x cubed. After 3, it's 2. After 2, it must be 3, 2, then 1. Because there's no x here, there's no x term like 2x, 3x, anything. So we actually put 0x, and then we have the constant. So it is exactly this one, just broken into pieces, because we took the 2x cubed, the minus x squared, the 0x, and then the 1. Right, so we good. Now let us do something else. Now, okay, we're done with the x squareds, but we don't do division anymore. We don't put anything. So here we just put r for the remainder, because obviously we're done. We expected the quotient to be a quadratic like this. So we have exhausted all the slots for the quadratic terms, or for the terms of the quadratic result, quadratic polynomial. And then now we have added all the x squareds, because it's like 3x squared. Now these are 0, 0. So it's 3x squared minus 8x squared. It's minus 5x squared. Then now you're dealing with the x's. 2x, 0x. 2x, 0x. And then what do we put here so that we get an x? And this x must be an x that appears in the numerator. And we can see that there is basically simply no x in the numerator. There's simply no x in the numerator, except that, so which means that since there's no x in the numerator, what do we have? So it can only be minus 2x that we put here. Okay, because 2x minus 2x will give us 0. Will give us 0x. We add these things diagonally. So it's like 2 minus 2, 0. So because we are suggesting that minus 2x because we did not have anything here, but we had 2x here. So we decide to put minus 2x because 2x minus 2x will give us 0x, because there's no x term in the numerator there. Okay. What is the next thing that we're doing? Okay, we're done with the x's. Now we're dealing with the constants. So there is a 0 here, but we must put something here that is going to add to the number here. So there's a 0, so 0 minus 1. Because 0 minus 1 is going to give us a minus 1. And it is exactly the minus 1 that appears here. That's why I put minus 1 here, because we must put anything so that when add here, it gives us the result there. So what then do we do? So as a consequence, what we're then getting is the following. It means, therefore, when we divide these two polynomials, we're getting a quotient. The result after division is called a quotient. So we have with us 3x squared. So this is the result, plus 2x. All right, 3x squared plus 2x. So we note that one. And then after having noted that, what else? We write everything. We write all the terms. So we've just written only the 3. So this is the result after division. We take the top here. We need to copy the 0 as well, but 0 is not going to change anything. Right, and then we copy the remainder. What is the remainder? It is minus 8 x squared minus twice x minus 1 divided by the divisor 2x cubed minus x squared plus 1, like this. So that is the answer. That is the answer. And therefore we're done. Okay, I just want to do this example. So please allow me to pause the discussion now, and then I'm going to be right back in like 15 minutes, and we're going to get started. I'm just going to process this video and upload the video, and then we'll continue with our discussion. Okay.
Okay, Sunshine.
Okay, thanks, Erato. Bye for now.
Goodbye.
Goodbye.